which tile below completes the wall next to it. Basically, which of this is the missing piece? Alright, so if I complete the shape, it will be easier to compare. So let me do that. So here I need to have a pointy things like this. Here I have to have something pointed like that. Here it needs to complete the circle. Here it should be like this. Now if I compare, now let's take these two. I need two pointed things. Here I have three, so this is definitely not going to work. Here there is only one, so this is not going to work. There are two pointed things. Here there is no pointed thing, so this is not going to work. There are two pointed things. Okay, now between these two, if I compare with it, you see that, I need here something like this and here like this, so that this matches, this doesn't match, right? So this is not it, is the correct choice. Amira is traveling from Atown to Betown and passes by two indicative signs along the road here. One of them has a hidden number, so this number is hidden. What is this number? Okay, now Betown has both the signs visible, so let me start with that. So Betown is this way. Let's say somewhere this. So let's say this is the Betown. Okay, so it says 9 kilometers from here. So this is 9. Okay, this whole thing is 9. But from here, this is 4, right? Okay, then what is this distance? So this distance has to be 9 minus 4, so this has to be 5, right? Okay, now Atown is this way, let's say somewhere it is here. Now, from here, I need to find this distance, but I know that this is 2. This distance is 2, but I also know that this distance is 5. So 5 is between these two signs, right? That is 5. So this is the same then. This has to be 5 too. This is 5. So 5 plus 2 is 7. So it has to be 7 kilometers from here. So this has to be 7. C is the correct choice. The board beside is formed by little white and dark squares. So this is the board. After a 90-degree turn, how can this board appear? So I have to turn it 90 degree, but I don't know whether I'm turning it like this or it could be also turning like this. So I don't know. I have to, check both. Now it will be difficult to compare the whole thing. So let me pick a small piece of it. Let me just pick this row. Okay. If it turns like this, it will come like here. But this will be a blue, white, blue and white. But if it turns like this arrow will be like this. I should see a blue, white, blue and white. Now, if I compare this blue, white, this doesn't match, this doesn't match, this doesn't match, blue, white, so this is matching, this doesn't match, okay? But it could also be turning like this, right? So on this side I should see a blue, white, blue, white, so this is matching. This doesn't match, this doesn't match, this doesn't match, this doesn't match, okay? So these two are matching for this row, but I need to then pick another row to eliminate one of these, right? So let me pick, we could put anything, but let me pick this row here. So this I should see as 2 white. From the tip I should see 2 white and 2 blue. So if it's turning like this, right? So from the tip I should see 2 white and 2 blue. Okay, so this is matching here. But if it turns like this, from the tip I should see 2 white and 2 blue. So I have 2 white and there is only 1 blue. So this is not matching. So this is not the correct choice. D is the correct choice. Anna starts lighting a candle every 10 minutes. Each candle lasts 40 minutes. And after 55 minutes, how many candles will be still lit? So, okay, let me mark some time. Let's say this is 0, 10, 20, 30, 40, 50, 60, so on and so forth. I will mark more if I need. So, at 0, I will lit a candle and it goes until 40 minutes. 0 plus 40 is 40. And then every 10 minutes I lit. So, at 10 minutes I lit. So, 10 plus 40, it will go until 50. 20 plus 40, it will go until 60. 30 plus 40, it will go until 70. 40 plus 40, it will go until 80. and I need to check after 55 minutes. So I need to check here. So I still need to lit a candle here. 50 plus 40 will go until 90. And then next one I lit at 60, that will go until 100 here. 100. But I need to check here. So here there are 1, 2, 3, 4 candles are still lit. C is the correct choice. Okay, there is a card here. If I flip it like this, I see the kangaroo. If I flip it like this, what do I see? Okay, now the picture of the kangaroo is difficult to draw, so I'm going to represent it with some lines. This is the head and this is the tail. Now if I flip it back, I will see this. Now if I flip this on this side, I'm going to see this. So the head, bottom, and the tail is like this. D is the correct choice. Bia has 5 coins as shown here. She went to the grocery store to buy a fruit using only 3 coins, okay, without having to receive a change. Among the prices of the following fruits, which one can she not buy? Okay, $1.30. So I can see that I can take this, this and this. So this is $1.30. I can make this. So this is fine. $1.35. I can take this 1, 25 and 10. So I can also buy this. So that's fine. $1.40, $1.40. Seems like I cannot make that. So let's continue. See, check the other ones. $1.55, $1.50, and this I can make this too. $1.75 will be okay. $1.50 and 25, that will be $1.75. So this is the only one I cannot buy. Then C is the correct choice. In a garden, a bush has branches with 7 leaves or branches with 4 leaves and a flower. Janaina counted the leaves and flowers and verified that there are 9 flowers and 120 leaves in the bush. How many branches does the bush have? Okay, a bush has either 7, the branches has either 7 L for leaves or a branch with 4 leaves and a flower plus a flower. Okay, and then total we count 9 flowers and 120 leaves. So the flowers must come from these branches because this doesn't have any flower. So I have 9 flowers. Each branch has only 1 flower. So I need 9 of these branches. So 9 times 4 is 36 leaves and 9 times 1 is 9 flowers. So flowers are accounted for now. So this gives me 36 leaves. So the remaining is 120 minus 36 is going to be 4. 11 minus 3 is 84. So I need 84 more leaves. So these leaves must come from this branch which has only leaves. So 84 by 7, this is going to be 12. So I need 12 of these branches. I need 9 of these branches. So that gives me total of 12 plus 9 is 21. There must be 21 branches. Cynthia paints each region of the figure in a single color, red, blue or yellow. She paints with different colors the region that touch each other. So if the 2 regions touch, they have to have different colors. How many different ways can Cynthia paint the figure? Alright, so we can just try. Let me use R for red, B for blue and Y for yellow. So let's start from the center, okay? So this, let me start with R for red. It can be red, blue or yellow. So this can be 3 different ways, but I'm just starting with any one, okay? Once I choose this, I have 2 other colors left. So let me, either blue or yellow, let me say choose blue, but I could have chosen this 2 different ways, either blue or yellow. So times 2, okay, red, blue, but once I have chosen these 2 colors, this I don't have a choice. If this is red, this is blue, this has to be a yellow, okay? And Once this is yellow, so this is touching blue and yellow, so this has to be a red. There is no choice there, right? Now, if you look about this one, so this is touching red and yellow, so this has to be a blue. There is no choice there. Here, this is touching red and blue, so this has to be yellow. There is no choice there. Now, this is touching yellow and blue, so this has to be a red. There is no choice there again, right? So 3 times 2 is 6 different ways. Similarly, you can try to start from outside and argue the same way and see if you can come up with the same answer. Actually, you don't have to start from inside or outside. You can actually start from anywhere. So pick any region that will have 3 choices, red, blue or yellow. Once you choose that, the one touching that will have only 2 choices, because if you choose red or blue or yellow, you cannot choose the same color again, so only 2 will be remaining. And the ones that is touching those 2 will have 1 choice, and similarly, just the way we argued here, the other regions will have only 1 choice as each, so this will result in the same number. 5 boxes contain 2, 3, 4, 7 and 15 balls respectively. Peter wants to distribute the balls into the boxes so that any box has twice or half the number of balls in one of the remaining boxes. At least for how many balls should he change boxes? So I have 2, 3, 4, 7 and 15. If I take 2 and 4, it is matching. So 2 has twice of that, that is 4. 4 has half of that, that is 2. The problem is with 3, 7 and 15. Okay? Now, if I take 3, if I do half, there is 1.5 ball. That is not possible. I cannot divide a ball. But I can have twice of that. 3 needs to have 6. So if I make this 6, I have to take away 1 ball. And that has to go here so that these 2 match. So this will be, 16. But 16 doesn't have half of that or twice of that, right? So this is not going to work. Let me take 7. Half of 7 is not possible. 3.5, I cannot have 3.5 balls. So if I make twice of that, so 7 is 14. So if I take 1 ball away from this, if I make 14 here, so this is matching, and give that ball that I took and make this 4. Now here in this case, if I take any box, the remaining boxes, one of the remaining boxes will have either twice or half. It is matching. So I'm changing, for 1 ball I'm changing the box, and A is the correct choice. But this question is actually a little bit confusing. Here I end up with 2 boxes, they have the same number of balls, but I think that should be fine, because the question doesn't say that one of the remaining boxes cannot have the same number of balls. 2 little mice, one white and one dark, live at the same time towards the cheese through different paths as indicated in the picture here. Okay, in which the little squares are equal, so these are all same squares. The 2 arrive at the same time to the cheese. So they start at the same time, arrive at the same time. If the dark mouse runs at 4.5 meters per second, how many meters per second does the white mouse run? Okay, so we know that, speed, we call it S, is distance covered by the time. And I know that, they start at the same time, arrive at the same time. That means the time taken is the same. So this gives me time is equal to distance over speed. Distance over speed. I'm doing like this so that I can equate the time for both. So time is distance over speed. So distance over speed for the white mouse, this has to be same as distance over speed, which is time, for the dark mouse, D for dark. Okay. Now, what is the distance? Let's check for the white mouse. It has to be 1, 2, 3, 4 units. So D is 4 units. for the white mouse. For the black mouse, it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is 12 for the dark mouse. And I know the speed for the dark mouse is 4.5. Okay, so this is 4.5. Okay, so what is this number? So this 4 times 3 is 12. So this is here, if I flip everything, so the speed is going to be, for the white mouse, is going to be, if I flip this, 4.5 divided by 3, so that is going to be 1.5. B is the correct choice. The circles of the figure should be numbered from 0 to 10, each with a different number. The 5 sums of the 3 numbers written on each diameter must be odd numbers. If one of the sums is the smallest possible, what will be the largest possible value of the remaining of the sums? Okay, so we have numbers from 0 to 10, so there is 11 numbers, and the 5 sums, so this is of 3 numbers, so 1, 2, 3, since 1 sum, 2 sum, 3, 4, 5, these are the 5 sums. Okay, one of these sum is the smallest. Okay, so let me write down the numbers from 0 to 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So total there are like 1 to 10, there is 10, and this is extra. So we have total 11 numbers. And there are 10 circles on the perimeter, 1 at the center. So there is 11 numbers total. Okay. So it says that, the sum of 3 numbers must be odd numbers. So how do I get odd numbers? If I add for even and even, I get an even. If I add odd and odd plus odd, I get an even. Odd plus even is odd. So the only way I get an odd sum is I add an odd number with an even number. Okay. So I have all the 5 sums are all odd numbers. Okay, so if I take a look at these numbers, which are the odd numbers? So this is odd, 1, 3, 5, 7, and 9. So I have 5 odd numbers, and the remaining 6 are even numbers. That means, one of the even numbers has to go at the center, so that the remaining 5 odd and 5 even can be on the diameter, and then when I add, there will be 2 even numbers and 1 odd number. So even plus even will be even, and then when I add that with the odd number, it will be an odd number. Alright, so one of the sums is the smallest. So how do I get the smallest sum? I can take the smallest of the 3 numbers. So 0, 1 and 2. 0 plus 1 plus 2 is 3. So this is the smallest odd sum I can get. Okay. Now the question is, what will be the largest possible odd sum from the remaining sums? So the largest possible will be, I take the, so I need a even and odd. So I take the largest 2 numbers, and then these 3, out of these 3 numbers, one will be at the center, right? So which one I want to be at the center? So this sum, I want it to be the largest. So then I want to put the, and at the center, remember that it needs to be an even number, right? So I want to put 2 at the center then. 2 at the center, and let's say this is 0 and 1. So this gives me 3, that is the smallest sum. And then I want to put 9 and 10 let's say this is 9, this is 10. So this should give me the biggest odd sum. So there is 9 plus 10 is 19 plus 2 is 21. Then E is the correct choice. When the bat Elisa left its cave at night, the digital clock showed this time. When she came back in the morning and hung herself upside down, she looked at her watch and saw this time. How long did she stay out of the cave? Okay, so this is not the actual time. This is how the bat is saying hanging upside down. So let's say this is the bat hanging upside down. So we read from left to right. So let's say this is left, this is right. So we read it like this. When the bat unhangs, right, or stands normally, it is going to read left to right. So it is going to read this way. So if you can imagine, try to look from the top, you read 0 to 0 1. 0 to 0 1. So this is the actual current time. And the bat left at this time from here to midnight. So this is going to be 1 hour and 40 minutes, right? And then this much time, so I have to add that 1 hour 40 minutes here. So this is 3 hours and 41 minutes. So D is the correct choice. If you have difficulty imagining this, you can write it down on a piece of paper and try it. So I have done that. So 1020, 1020. So this is how the bat is saying hanging upside down. So you try to, unhang, or you can just flip it instead. And then we will see 0201, 0201. On a distant island, 20 kangaroos holding hands form a large circle. These kangaroos are either brown and they always tell the truth, or they are grey and they lie. Each of them says the same thing. One of my neighbors is brown and the other is grey. What is the number of brown kangaroos in the circle? Okay, we can start with a brown or a grey kangaroo. So let me start with a brown kangaroo. So brown tells the truth. So on one side there has to be a brown, the other side there has to be a grey. So this is taken care. So this brown also tells the truth. So on one side there is already a brown, the other side there has to be a grey. So this is taken care. This grey kangaroo is lying. So on one side there is a brown, the other side there cannot be a grey, it has to be a brown. This is taken care. This tells the truth. On one side there is a grey, so the other side there has to be a brown. This is taken care. Similarly, this is telling the truth. So on one side there is a brown, the other side there has to be a grey, so this is taken care. So on and so forth. So you can probably see the pattern here. So brown, brown and grey, brown, brown and grey. So this pattern is going to repeat, right? So total how many kangaroos are there? Total there are 20 kangaroos. 20, and each pattern there are 3 kangaroos. So if I divide it by 3, this is 6, and then 22, 7, then 1. So there will be 1 kangaroo left over. If I group 3 in each, 1 kangaroo will be left over. Where can I put this kangaroo? And is this kangaroo going to be brown or grey? Let me try a different color. Let's say this kangaroo is brown. Okay, I'm just assuming, I don't know yet. Where can I put that kangaroo? Can I put that kangaroo here? I cannot put the brown kangaroo here, because then this will not be telling the truth, right? Because on both sides they are brown. So I cannot put brown kangaroo there. Can I put it here? If I put the brown kangaroo there, this will be not telling the truth, right? So again, I cannot put the brown kangaroos here. Similarly, you can assume that this is a grey kangaroo and try different position, and you will see that you cannot put the remaining 1 kangaroo anywhere, whether it's brown or grey. So this is not going to work. And remember, I started this with assuming a brown kangaroo. So let me start with a grey kangaroo. Let's say it's a grey kangaroo, and I know that the grey kangaroo lies. The way it can lie is, either both sides there are brown kangaroos, then this is lying, right? Because it's saying that one of my neighbor is brown, the other is grey, which is not true, both are brown. Or the other way it can lie is there is a grey kangaroo, on both sides there are grey kangaroos. Then this will be lying. So it can lie this way or this way. Now, in this case, the brown kangaroo is telling the truth. So on one side there is grey, so the other side there has to be a brown. And you will see that, this will lead to this pattern, and again, that is not going to work out. On this case, you will see that, okay, if this is lying, there has to be a grey on both sides, there will be a grey on both sides, so on and so forth. So all the kangaroos are going to be grey kangaroos, right? So this is the only case that is going to work actually. So there will be no brown kangaroos. A is the correct choice. Maria has exactly 9 white cubes, 9 light grey cubes, and 9 dark grey cubes, all the same size. She glues all these cubes together to form a large cube as shown. Which one of the cubes below is the one she made? Okay, we can simply count and check. Let me call white as W, light grey as L, and dark grey as D. So let me W for white, light grey for L, D for dark. And I count here. Let me count the white. White, I only see 1 here. So 1. Then light gray is 1, 2, 3, 4, 5, 6, 7, 8, 9. I see 9 of the light. And then dark gray is 1, 2, 3, 4, 5, 6, 7, 8, 9. I see 9 of that. Okay, let's come here. White I see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. White I see 10, but there cannot be more than 9, so this is not going to work anyway. Similarly, actually you can count the other ones and you'll see that, this is the only one that is going to work. We see 9 of each. The remaining 8 of the whites are hidden. The following figures show 5 paths indicated by the thick lines as shown here between x and y points. Which of the path is the longest? Alright, so the key to notice here is that if I have a circle and if I draw 2 lines passing through the center, this length is going to be same as this length, and then this length here is going to be same as this length here. Okay, so that is something to keep in mind. And then you can simply count here. So this length is going to be same as this length. So we have basically 2 of this. So let's count quarter circle as 1 unit. So there are 2 units of that. So there is 1 unit here, another one here. So there are 2 of this. Here there is 1, 2. So there are 2 of these 2. And this line I have 1, 2, 3, 4, 5. So 5 of this. Okay. One thing to note is, it is not given to us that, this distance is same as this distance, but it looks the same. So I'm assuming it's the same. Let's count this one now. I have 1, 2. So there are 2 of this. Here there is 1, 2. So 2 of this. For this one, I have only one. And then this line I have 1, 2, 3, 4, 5. So I have 5 of this. So if I compare these two, so there are 2 here, 2 here. So this matches. And then the next one, I have 2 of this, 2 of this. That's matching. The next circle, I have 1 of this. Here I have 2 of this. Okay, so this is not matching. So I have more here, more of the smallest circle. And then this, I have 5 of this, 5 of this. So this is matching. So this is matching with this. So we can already see that this is longer than this one because, I have an extra one of this, the smaller one. So this is not going to work. Similarly, you can check the others and you will see that, this is the longest. Mary numbered the sides of 3 cards from 1 to 6. Using these cards, she can compose 3-digit numbers, for example 135 or 234, but some numbers cannot be obtained like 126. Which of the following numbers cannot be obtained? Okay, so we can make 1, 3, 5. Let's say these are my 3 cards. 1 card, 2 card, 3 card. Okay, I can also make 2, 3, 4. So I'm going to write down the 2 sides of the card here. So if I make 2, 3, 4, I can make 2, 3, 4 like this, or 4 can be on this side, 2 can be on this side too. So I can also make 2, 3, 4 like this. Okay, but I cannot make 1, 2, 6. That means this 1 and 2 must be on the same card, right? That's why I cannot make 1, 2, 6, right? So that means this configuration is not the 1. This is the configuration, and on the other side of card 3 has to be the number 6. Okay. So which of the following numbers cannot be obtained? 1, 3, 4. Let's say 1, 3, 4. I can make it 1, 4, 6. 1, 4, 6, I can make it. They're from different cards. 2, 3, 5. 2, 3, 5 is fine. 2, 4, 5. 2, 4, 5. This one I cannot make it. 2, 5, 6. 2, 5, 6. They're from different cards. I can make it. So then D is the correct choice. Which of the following indeformable pieces of wire, when duplicated, allows to make a closed piece without crosses with the 2 pieces joined by their ends? This requires a little bit of imagination, but just by looking at it, seems like this is the one that is going to work. Let me actually just complete the grid here. Let's see. Okay, let me change the color. Okay, so I want this end to go like this here, and then one like this, one like this, then this, this, this. So as you can see, this piece is same as the original one. They are basically a copy of each other, and I can make a closed loop. So B is the correct choice. Amelia drew 6 stickers on the face of a cube. Okay, these are the stickers. The figures show the cubes in 2 different positions. So these are the 2 different positions. Which adhesive is on the opposite side of the duck? Okay. So we try to find something common in both. So in this case, the ladybug. So and then try to place the stickers with respect to that. For example, we can see that at the head of the ladybug there is a dog. So at the head, so there has to be a dog. So D for dog on the bottom. Okay, and to the right of the ladybug there is the fly. So to the right of this ladybug, so there has to be a fly on this side. Okay, so the rabbit is done. Elephant is not there, so this must be the elephant, right? And then elephant is done, duck is done, ladybug is done, dog, D for dog is done, F for fly is done. Okay, so this is the configuration. So we want to find opposite of the duck. Opposite of the duck is going to be the fly. E is the correct choice. Beatriz has 5 sisters with ages here. She writes the ages in the circles of the opposite diagram, of this diagram, so that the sum of the edges in the 4 corners, okay, of the square is equal to the sum of the edges in the 4 circles aligned horizontally. Okay, here, what is this sum? Okay, so the sum of this is same as sum of, you know, this that is given to us. Now we can see that, so this is the same, this is the same, right? So the sum of these two numbers has to be same as sum of these two numbers, right? Sum of these two numbers has to be same as sum of these two numbers. So I have to find two pairs of numbers that add up to the same number. Now if I look at the ages, I see that 5 plus 8 is 13, and then 3 plus 10 is 13, right? So that means, you know, so this can be, you know, 5 and 8. This can be 3 and 10. The remaining numbers, 2 and 17 has to go here. 2 and 17 has to go here. So the, you know, the sum is that 8 plus 2 is 10, plus 5 is 15, plus 17 is 32. D is the correct choice. Maria puts 4 liters of water in vase 1, 3 liters in 2, and 4 liters in 3. Okay, so 4, 3, and 4. Okay, seen from the front, these three vases are the same size. Okay, this is same as this, is same as this. Which of the following images can represent the three vases when looking from above? Okay, from the top, which one of this is correct? Okay, let's first compare these two. They have the same amount of water and same length. That means, you know, since the height is less here, the depth has to be more, right? So 3 has to be greater than 1, right? The depth, in the depth direction, 3 has to be greater than 1. So 3 is greater than 1 here, that's fine. 3 is smaller than 1, so this is not going to work. 3 is smaller than 1, this is not going to work. 3 is greater than 1, that's fine. 3 is same as 1, this is also not going to work. Now, we can compare either these two or these two. Let's just compare these two. So, this has more water, right? This has less water, but this dimension is same, so the depth has to be more for this, right? So, 1 has to be greater than 2. Okay? So, 1 is greater than 2, so this seems fine. 1 is less than 2, so this is not going to work. Then A is the correct choice. Inside the gray square, there are 3 white squares, and the numbers inside them indicate their areas. Okay, so this is a big gray square, and there are 3 white squares inside. Okay, the white squares have the sides parallel to the sides of the gray square. That's fine. That's clear from the picture. If the area of the gray square is 81, okay, the whole area is 81. What is the area of the gray area not covered by the white square? Okay, gray area not covered by the white square. That means what is the area of this and this? Okay, so it's not asking this, by the way. Okay. Okay, so this whole area is 81. So that means the side has to be 9. So 9 times 9 is 81. So this whole length has to be 9. Since the area is 9 here, this side has to be 3. 3 times 3 is 9. Since the area is 4, the side length has to be 2, because 2 times 2 is 4. Okay? Then, what is this side here? So this is 9 minus 3 minus 2. So that is going to be 4. So this side is 4 then. So 4 plus 3 is 7 plus 2 is 9. Okay? Now, so this area then is 16, right? So the area here is 16. Okay? So the gray area that is not covered is the total area minus these 3 areas, right? So this is 3 plus 16 plus 4. So this is 16 plus 4 is no, so this is 9, right? So this is 9. 9 plus 16 plus 4. 16 plus 4 is 20. Plus 9 is 29. So 81 minus 29 is 52, right? Then C is the correct choice. John made a construction with wooden cubes of the same size with the three views shown beside, front, right, and top, using as many cubes as possible. Alright? Anna, John's sister, wanted to remove all the cubes she can without modifying these three views. At most, how many cubes can she remove? This is actually a very hard problem unless you know the technique. So let me show you how to do this. So here there are three cubes. Let me write down the number of cubes here. 4, 3, and 3. Similarly here there are 4, 3, 2, 3. Okay. We want to copy over these numbers to the top view. So let's say front view is from this side. So 3, 4, 3, 3. I want to write that down. 3, 4, 3, and 3. And this will be my right view. So I want to write down this number. 4, 3, 2, 3. 4, 3, 2, 3. Okay. Now, to find the maximum number of cubes to get this view, this is what we do. Take a column and a row, and whatever is the minimum of that, write in that cell if there is a cube in there. So this is 3, this is 4, minimum is 3, but there is nothing here, so I don't have to do anything. This is 4, minimum is 4, so I write that down here. 4, and this is 3, so this will be 3. 4 and 3, 3. Similarly here, this will be 3, 3, there is nothing here, this will be 3. So this will be 2, 2, 2. This will be 3, 3, and 3. Okay? Now, if I add all these numbers, that will give me the maximum number of cubes. So let me add it. So this 3 is 9. This is 2 plus 2 plus 2 is 6. This is 9. And this is 10. So the total, I have 9 plus 9 is 18. Plus 6 is 24. 34. So this is the maximum number of cubes I need to use to get these three views. Now, we wanted to see how many of those cubes we can remove. So, this is how we do. Remember that we need to preserve these three views, right? So, let's pick the corner cubes, 3, 2, 3, 3, and see, just by keeping those, if I can maintain the, front and the right view. If I have 3 here, so this 3 is satisfied. If I have 2 here, this 2 is satisfied. If I have 3 here, this is satisfied. If I have 3 here, this is not satisfied. I need 4. Okay, that's fine. This 3 will satisfy this. This 3 will satisfy this. This 2 is not going to satisfy this. This 3 is going to satisfy this. So only thing that is remaining is this is 4 and 4. I want to get 4 here. Then I have to keep this one. Okay? In the remaining cubes that I have not circled, I can remove everything but 1. I cannot remove everything because then that place will be empty, right? So I can remove everything but 1. I just need to keep 1. So here I need to keep 1, so I can remove 2 and 2 from here. So I can remove 4 from this 2. Here I can remove 1 and 1, 2. Here I can remove 2 and 2. I can remove 4 there. And here I can remove 2 from here. Okay. So total, this is 8 plus 2 is 10, 12. So I can remove 12 cubes and I can still get the view, and you can verify it. If you make all these numbers that I have not circled 1, you will see that, you still have 3, 2, 3, 4. And here 3, 4, 3, 3. Okay. So I can remove 12. B is the correct choice. This is actually a hard problem, and if you don't know the right technique, it will be pretty difficult to solve. Now, there are some techniques, we have to just follow blindly, and then when you go to the higher grades, we get to know why those work. But in this case, we don't have to follow this technique blindly. We can try to understand why it works. And to help with that, I have some additional questions for you. But before that, let's just try to recap the technique. What we did is, we mapped the front and right view to the top view. So this is the front, and this is the right, and this is the top view. And then For a given column and row, we pick the minimum number. Similarly, we picked all the minimum, and if I add all the minimum numbers, I get the maximum number of cubes I can use to get these 3 views. Now, to get the minimum number of cubes to get those 3 views, I picked a diagonal and then try to see which numbers are satisfied. If something is not satisfied, I try to pick a off diagonal number for that, right? And the remaining cells, I reduce them to just 1. And then once I add those numbers, that gives me the minimum number of cubes I can use to get those 3 views. Alright, now here are the questions. Given a column and a row, I first pick the minimum. So why minimum? Why not the maximum? This is the first question. Now, to get the minimum number of cubes, I started with keeping the diagonal. But why started keeping the diagonal? Why not the off diagonal? Right? So there's a second question. Now, if you notice in this case, right, these two satisfied the right view, but it did not satisfy the front view. So can it happen that a diagonal will satisfy neither the front nor the right? Right? Can that happen? So that's the third question. Now, in this case, we mapped the front and right to the top view. So we took this as a base. But instead of that, can I use this as the base and map the other two to this? Or use this as the base and map these two to this? Can we do that? That's the fourth question. Now, in this case, I picked this diagonal because there is nothing in this diagonal. But let's say we went with this view. So instead of picking this diagonal, could I have picked this diagonal instead? Let me know. And if you can't figure it out, right, give it some thought. If you can't figure it out, let me know. I'll help. A panel is composed of 4 circles. When Lucy touches a circle, this circle and the others that touch this circle change their color from white to black or from black to white, as shown in the picture, right here. So if we touch this, the black will become white, and the 2 others that are touching will change color from white to black, and this will remain the same. Okay, starting with all white circles, all white. At least how many circles must Lucy touch one after the other so that all circles turn black? Alright, so let's start with 4 white. Let me first touch this one. If I touch that, that will become black. White will change color to black, and these 2 others they are touching, they will also change color. It will become white to black. Okay. Next, I want to touch this one. If I touch this one, this will become black. Black and black will become white and white. This black will remain the same. Okay. Now, let's touch this one. So this white will become black. This black and black will become white and white. This will stay white. Now, I want to touch this one. If I touch this, white will become black. White and white will become black and black. This black will remain the same. Now I have everything black. So I have, 1 touch, 2 touch, 3 touch, 4 touch to get all black. C is the correct choice. Which set of the weights below balances the third scale in the picture beside? Okay, which weights balances here? We basically have to just combine these two somehow to get to this. Okay, first we see that a circle and a triangle is 3 squares. So let me replace this circle and a triangle, get rid of that, and replace that with 3 squares. 1, 2, 3 square. And now I can take away 1 square from this side, 1 square from this side. So the arrow is then 2 square and a circle. Okay? Okay, that is one thing. And then, okay, I think we are set. So we have two squares and an arrow. So two squares is same as two squares, right? Arrow is, we know, a circle and two squares. That is same as this actually. So D is the correct choice. 10 people order an ice cream for each one. They ask for 4 vanilla ice cream, 3 chocolate, 2 lemon, and 1 mango. As a topping, they ask for 4 umbrellas, 3 cherries, 2 wafers, and a chocolate gum, 1 topping for each ice cream. Since they don't want the ice creams the same, which of the following combinations is possible? Alright, so these are the, I believe, the toppings that is shown. Okay, so I have 4 vanilla. Let me write V for vanilla. So I have 4 of those. 3 chocolate, C for chocolate, 2 lemon, L for lemon, and 1 mango. And these are the toppings. I don't want 2 ice cream to look the same. So let's start with vanilla. So I can have this vanilla, 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 vanilla. So vanillas are all different. Now the chocolates. So I can have this as a chocolate, chocolate, and chocolate. Lemon, I can have this as a lemon, this as a lemon, and mango, this as mango. So all ice creams are different. Now we can check one of the choices, right? We can see that lemon and cherry is possible, is the correct choice. You can check that the others are not possible. We say a 3-digit number is balanced if the middle digit is the arithmetic mean of the other 2 digits. How many balanced numbers are divisible by 18? And it has to be balanced. Okay, we can start with the smallest 3-digit number, which is say 100. And is it balanced? For it to be balanced, this plus this divided by 2 has to be this. But as you can see, it is not 1 plus 0 is 1, by 2 is half. So this is not going to work. Then we can take 101, 102, so on and so forth, right? But we can do better. We can be a little bit smart about which numbers we pick, okay? Now, we know that it has to be balanced. So let's start with, so it has to be a 3-digit number. So the smallest left digit can be 1. What can be the right digit? Remember that this plus this divided by 2 has to be this. So this plus this has to be divisible by 2. Now remember, since this is an odd number, this also has to be an odd number. Because odd plus odd is equal to even. Or, even plus even is even. But I cannot have a odd plus even, because odd plus even is going to be odd, and if I divide that by 2, I will not get an integer, right? So this has to be odd. So it can be, the smallest odd can be 1. So 1 plus 1 is 2, divided by 2 is 1. That can be one possibility. And then I'll continue with 1. And then it has to be a 3. 2 will not work because, 2 plus 1 is 3, that's going to be odd number. So it's not going to work. So 3 plus 1 is 4, divided by 2 is 2. And then I can have 5. 5 plus 1 is 6, divided by 2 is 3. Similarly, 7 plus 1 is 8, divided by 2 is 4. And then 9 plus 1 is 10, divided by 2 is 5. And then, then I'm done with 1. Then I can start with 2. 2 something and something. So here, I need an even number, because even plus even is even. So I can have 0. 2 plus 0 is 2. Divided by 2 is 1. And then with 2, and then I need to have a 2 here. I cannot have 1 because 2 plus 1 is 3. That's the odd number. So 2 plus 2 is 4, divided by 2 is 2. Similarly, 2, and then this has to be a 4. 2 plus 4 is 6, divided by 2 is 3, and then it will be, you can actually see the pattern here, 1, 2, 3, so this will be 2, 4, 6, and then 2, 5, 8, right? And that's it with 2, then 3. But, think about it. The other condition is it has to be divisible by 18. That means it has to be divisible by 2 times 9. Now, if it has to be divisible by 2, it cannot be an odd number, right? So, all these things that start with an odd number are not going to work. So, these are not going to work. Similarly, numbers starting with 3 are also not going to work. So, we don't even have to check that. So, we need to check only the even numbers. So, 2 and then 4 something and 0. 4 plus 0 is 4, divided by 2 is 2. Eight, 8, right? And that is it, right? Now, here, all these are balanced numbers, so that condition we have checked. They are also divisible by 2 because we have kept only the even numbers, right? The only thing that we need to check is if it is divisible by 9. And for a number to be divisible by 9, the sum of the digits have to be divisible by 9. So let's check that. 2 plus 1 is 3, that is not divisible by 9. 8 is not divisible by 9. 3 plus 2 is 5 plus 4 is 9, so this is divisible by 9. This is 24 is not divisible. So 1, 2, 3, 4, 5, 6 numbers are going to satisfy all the 3 conditions. They are going to be balanced and divisible by 18, right? Then C is the correct choice. Alright, doing it like this is perfectly fine, but if you are comfortable with algebra, we can do it another way. So it is a balance, meaning let's say the digits are A, B and C. So balanced meaning A plus C, arithmetic mean of that is the middle digit B, or this tells me A plus C is 2B. Okay, so this is one of the conditions. And then it has to be divisible by 18, meaning it has to be divisible by 2 and divisible by 9, right? So 2 times 9 is 18. Divisible by 2 means it has to be an even number, so C has to be even. C is even. This is the second condition. And then for it to be divisible by 9, the sum of the digits have to be divisible by 9. So sum of the digits is A plus B plus C. This has to be something times 9. But I know A plus C is 2B. A plus C is 2B. So this is 2B. So 2B plus B is 3B is equal to something times 9. So this 3 here. So B has to be something times 3. That means B has to be a multiple of 3. Okay. So what are different one-digit numbers that are multiple of 3? There are only few of those. It can be 0, 3, 6, or 9. That is it, right? So these are the only possible choices for B, that is the middle digit. Now, if it is 0, what can be these 2 digits? So the sum of these 2 digits, A plus C, has to be 2B. So 2B is 0. So these two, sum of these two has to be 0. So it can be 0, 0, but then there is not a 3-digit number. So this is not going to work. Now, here, the sum of these 2 digits is going to be 6. And then this has to be even. So the choices are, so the sum has to be 2 times 3 is 6, right? So 2B, the sum has to be 2B, that is 6. So 6, how can I get 6? It can be 0 plus 6. It can be 2 plus 4. Or 4 and 2, 6 and 0, that's fine. And that is it, right? So from here, I can have, I can get 0, 3, 6, but this is not a 3-digit number, it's not going to work. but 6, 3, 0 is fine. And then 2, 3, 4, 2, 3, 4 or 4, 3, 2, 4, 3, 2. Okay, so I get 3 from here, right? Okay, now if it is 6, the sum of these two digits has to be 2 times 6 is 12. So how can I get 12? I can get 2 and 10, but I cannot have a two digit number, so it's not going to work. So it has to be 4 plus 8 or 8 and 4, and then 6 plus 6, right? That's how I can get 12. So then from here, I can get 4, 6, 8 or 8, 6, 4 or 6, 6, 6, right? Okay, so these are the 3 more. From 9, now the sum of A and C has to be 18. What two single digit numbers will give me 18? Only 9 and 9, but this has to be an even number. So 9 is not an even number, like this digit is not going to be even number, so this is also not going to work. So we left with these 3 here and these 3 here. So again we have only 6 of those, and we can verify 630 234, 630 234, 432, 432, and then 468, 864, 468, 864, and 666, 666. We get those 6 numbers. This was a really nice problem, and I made a demo that I'm really excited to show you. So we start with all the 3-digit numbers from 100 all the way to 999. So there are 900 of those, and then we slowly start applying the conditions one at a time. Let's first make those balanced. So that leaves us only with 45, the ones that are highlighted here. And then we are going to apply the conditions divisible by 2, because remember we have to make it divisible by 18, that means it has to be divisible by 2 and then 9. Okay, so if I make it divisible by 2, so then I'm left with only 20 of those, right? And then finally I want to make it divisible by 9, then I am left with 6, and as you can verify, these are the same 6 that we got earlier. Another thing I wanted to point out is, depending on the order that we apply the conditions, it can be a little bit easier or more difficult to solve. Let's say, for example, if I first apply the conditions that it has to be divisible by 9, then I still have 100 left, and then I make it divisible by 2, I still have 50 left, and then if I apply balance, of course I will end up at the same answer, right? It has to give me the same answer, but depending on how we apply the conditions, it can be easier or more difficult. Janaina bought 3 toys, spending all her money. For the first one, she paid half of the money she had plus 1. Okay, for the first one, she paid half of the money plus 1. For the second one, she paid half of what was left plus 2. For the third one, she paid half of what was left plus 3. How much money did she have? So there are a few ways we can solve this problem. Let me show you the easiest one first. We can try each choice, one at a time. So let's try the 34. So for the first toy, I start with 34, half of what I had, plus 1. So this is going to be 17 plus 1 is 18. I paid 18, so I'll have left with 34 minus 18 is going to be 16. Okay. So for the second, I paid half of what was left, that is 16. Half of that plus 2 plus 2. So this is going to be 8 plus 2 is 10. So I'll have left with, I had started with 16, I paid 10, so I'm left with 6. So for the third toy, half of what was left, that is 6. Half of that plus 3. So this is going to be 3 plus 3 is 6. So I'm left with 6 minus 6 is 0. So I'm left with nothing. And that's what we want because we spend all the money. So this works out, and Math Kangaroo has only one correct choice. So this must be the correct choice. You can try the other ones and you'll see that they will not work. Alright, let me show you another way how to do this. So for the first one, let's say I start with this much money and I spend half of that plus 1. So I'll be left with half of that minus 1, and I need to figure out how much is that. Okay, let's say this is another amount. So for the second toy, I pay half of that plus 2. So I'll be left with, half of that minus 2. So if you add these two together, you just get a triangle. And we call this another symbol. So for the third toy, I pay half of this plus 3. So I'll be left with, half of that minus 3. But I know that at the end, I spend all the money. So I'll be left with nothing. Now, if you take a look, if we start from the beginning, there are two things I don't know, so I'll be stuck. But if I start backward, if I start from the end, here only one thing I don't know. I can figure this one out. If I figure this one out, I'll figure this one out. If I figure this one out, I will know this, right? So let's do that. So here I can see that, take the 3 to the other side and multiply 2. So this has to be 6. So if this is 6, take 2 to the other side. This is 8 times 2 is, so this is going to be 16. If this is 16, take 1 to the other side, that is 17 times 2 is 34, right? So I start with 34, we get the same answer. Finally, we can also do this using algebra. So let's try that. Let's say I start with X amount of money. For the first toy, I pay half of that plus 1. So if I subtract, this is the amount of money I have left with. This is going to be, this is 2x minus x minus 2. So this is going to be x minus 2 by 2. So this is how much money I will left with after buying the first toy. For the second toy, I start with this x minus 2 by 2. And how much I pay? I pay half of this. So that is x minus 2 by 4 plus 2. Plus 2. So if I take this away, how much money I'll have left with? So this is going to be 4. 2x minus 4. And this is going to be minus x plus 2. Minus x plus 2. This is minus 8. Minus 8. And this is going to be 2x minus x is simply x. So this is minus 2. So x minus 10 over 4. Okay. So for the third toy, I start with this amount of money, x minus 10 by 4. X minus 10 by 4. And I pay half of that. So that is x minus 10 by 8 plus 3. Plus 3. Plus 3. So I'll be left with this much. So this is going to be 8. So this is 2x minus 20 minus x plus 10 minus x plus 10, and then minus 24. Minus 24, right? So this is going to be 2x minus x is x. And then this is minus 10, minus 24 is minus 34 over 8. But I know that finally I spent all the money, so this must be 0, right? So this must be 0. So this tells me that x has to be 34. I get the same answer. D. Build the sculpture on the side by doing cubic boxes of half a meter on the side. So this side basically is half. Okay. Then she painted the sculpture minus the support base with a special paint sold in cans. Each can allows to paint 4 square meters of surface. How many cans? Okay. How many cans of paint did she have to buy? Okay. So basically we need to find the exposed surface area. Now, here is the trick. If I look from the top, if I take the top surface of this, all this top surface, all this top surface, all this top surface, right? So this should be extending like that. So all those top surface, if I add it together, that will be this times this, right? Okay, so what is this? So this is, each is half. So 1, 2, 3, 4 times half. So this is going to be 2. So each side, so this is 2. This is then 2, right? So this, the top surface is going to be 2 times 2. So that is the top surface, okay? Plus, I have to add the side surface. Now, as you can notice, side surface is nothing but, take one side and multiply by 4, right? So one side, whatever that is, times 4. How much is one side? One side is, first let's count how many of these surfaces are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 10 of those times surface area of 1. Surface area of 1 is, this is half times half. So this is half times half. So this is going to be 5, 2, so this is 10. So this is 4 and this is 10, so that is 14, right? Okay, so each can allows 4 square meter. So how many cans I need? So 14 by 4 is, so this is 3 plus 2 by 4. So I need 3 full cans and a little extra. So I will have to buy 4 cans. Vania has a sheet of paper divided into 9 equal squares like this. She wants to fold the sheet as shown in the picture. Okay, initially with horizontal folds like this, and then with vertical folds like this. Okay, until she leaves the colored square on the top of the layer. Okay, so this will be at the top. She wants to write the numbers from 1 to 9, 1 on each square, so that the numbers are in ascending order, meaning 1, 2, 3 like that. Starting with the number 1 at the top. And basically it is asking what will be here. Okay, so it requires a little bit imagination. You can also, use a piece of paper and do this yourself, but it's not too hard to imagine. As you can see, when I fold it like this and like this is at the top. So this will be 1 and then in ascending order. So there are 3 squares here. Those are going to be these 3. So this will be 2 and 3. 1, 2, 3. They're together. And then it's folding like this. So this is coming from the back. So the bottom, this one has to be 4. Because the numbers has to be on the ascending order from the top all the way to the down. It's 4, 5, and 6, right? And then it folds like this. So this has to be 7, 8, and 9. So I can see that A is 7, and this is the correct choice. The figure shows a map with some islands and how they are connected by bridges. A navigator wants to pass through each of the islands exactly once. Okay, he started at Can here, island, and wants to finish at Uru here. Okay, he has just arrived at the black island here in the center of the map. In which direction must he go now to be able to complete his route? So from here, where should he go? This just requires a little trial and error. So I actually tried for some time and then realized that, the only way we cover this middle strip is this. That's the only way we can do it, right? And then basically connect this here and this here. Okay, that's the only way, right? So basically, if we are starting from here, we see that if we arrive here, we have to go south. Then C is the correct choice.